Right, so for this example, graphing circles, working with equations of circles, um, what we're going to do for this one is I'm going to use a little bit different looking equation than what the formula represents. Um, if we go back and look at our formula for the equation of a circle, if you recall, it looks like x minus h squared plus y minus k squared is equal to r squared, or the radius squared. So that's what our general formula for the equation of a circle looks like, where the values that change in the circle is going to be the center point and the radius. That kind of defines, where our circle is located and the size of the circle. And then the x in our equation and the y in our equation stay in that equation because those represent the points around the circle. So those values can and do change depending on what specific point you're looking at on the circle itself. For this one, what we're going to look at is a circle that's centered at the origin. So we're going to look at a circle that's centered here and what the equation of that circle is going to look like. Now, if we look at our coordinates for that center point, the origin is always 0, 0. So if we plug that into our equation, I'm not going to worry about the radius at the moment. I'm just going to focus on the left side of our equation, the x minus h and the y minus k part. If we plug that center into our equation, we're going to get something that looks like this. X minus 0 squared, x minus 0 squared, plus y minus 0 squared equals r squared. And then the radius, like I say, can change depending on the size of our circle. Okay? In general, if we take 0 away from a number, we end up with the same number that we started with. So, for example, if I have x minus 0, well, that simplifies to just x, because if I start off with x and I don't take anything away from it or add anything to it, I still have x. So this first part of my equation then can simplify to just simply x squared. All right? And now if I look at doing the same thing with this part of my equation, the y, well, the y part, I'm taking 0 away from it as well. So that one I can just simplify to y squared. And then I'm not really changing anything with my radius. So my radius is still just a number, radius squared. So any circle that's centered around the origin has a center point at the origin is going to look like x squared plus y squared equals the radius squared, so whatever your radius is. The circle I have up here, I made a radius of 4. So my equation for that circle would be x squared plus y squared is equal to, remember, whenever we're writing our equation, we have to square the radius. So I would have 4 squared. Now to kind of simplify that a little bit, you could leave it as 4 squared, that's perfectly acceptable, or we can go ahead and calculate that out, and we will get the equation x squared plus y squared is equal to 16. So any circle that's centered around the origin that we have the graph of, or we're trying to graph, we're looking for this specific pattern, x squared plus y squared. So I'm going to draw one more circle up here, centered around the origin. And we're going to see how this equation changes, as opposed to the first, from the first equation. So again, only thing I've changed, I still have the center at 0, 0. So I'm going to start off my equation with x squared plus y squared. And now I just have to see what is my radius now. So if I count outward, 1, 2, 3, 4, 5, 6, 7, 8. Now I have a radius twice as big. So my radius is 8 squared. And then kind of simplifying that or calculating that, I get x squared plus y squared is equal to 64. Okay?